The James Webb Space Telescope has just produced what is perhaps the most significant find in human history: evidence for city lights, artificial light, on a planet a mere 4 light-years from Earth. When the data began to flow back, showing faint but unmistakable light patterns across the black hemisphere of Proxima Centauri b, a jolt of electricity coursed through observatories, research institutions, and science centers around the world. It was a find that thrilled the scientific community, shook the very foundations of our comprehension of the universe and our place in it. Over the decades, astronomers had chased faint hints of alien technology, unexplained infrared signals, mysterious radio flashes, strange spectral signatures that couldn't be explained by known natural processes. But now, for the first time in the history books, centuries of guesswork and long-waiting observation had distilled into one brief, breathtaking moment of verification. There were lights on Proxima b. Not natural. Not random. But regular, structured, and hauntingly familiar, a reflection of Earth's own city softly glowing in the emptiness. Equipped with a suite of groundbreaking infrared instruments, the James Webb Telescope had been making an ongoing series of deep space surveys with unprecedented accuracy. Among its most painstakingly designed targets was Proxima Centauri b, a rocky Earth-sized world orbiting in the habitable zone of our closest neighboring star. Previous missions, such as those conducted by the Hubble and Spitzer telescopes, had all been aimed at detecting atmospheric biosignatures, gases such as methane, oxygen, or water vapor that could provide a possible indication of biological processes. But on this observing run, something radically different caught Webb's keen detectors: an insistent but subtle mid-infrared radiation excess emanating from the night side of the planet. It was much too uniform and much too warm to be explained by volcanoes, seasonal climatology, or geological activity. That was followed by an intensive months-long scrutiny by hundreds of scientists and engineers on the international scene. All possible sources of error were explored. The pipeline of data processing was recreated from scratch. The internal calibration of the telescope was thoroughly combed over. Advanced machine learning algorithms were used to separate natural background noise and anomalies. With each skeptic's objection spent and each source of error removed, the conclusion was unavoidable: the light was man-made. Spread across the planetary disk in plain geometric patterns, the lighting carried the unmistakable signature of city grids, power grids, and techno-infrastructures. The victory was possible only due to the phenomenal abilities of Webb's mid-infrared instrument, MIRI, which was built to reveal the weakest thermal emissions in the coolest areas of space. MIRI could filter out light emissions as short as 10 microns in wavelength, a wavelength band perfectly suited to detecting artificial warm sources such as city lights. Scientists had speculated for decades that if any extraterrestrial civilizations made cities with light, their radiative signal would be detectable in just this range. Now, those models were confirmed by observation. This wasn't hope. This was information. This was a civilization that had overcome the night. The implications of this finding extended to every academic field and provoked philosophical reflection on a worldwide basis. In the world of astrophysics, it confirmed the new field of study of technosignature science, a discipline that looks beyond biology and instead concerns itself with the alien technology's detectability. Proxima b was also a contentious case for habitability because of its close proximity to a red dwarf known for its flaring and its probable tidal locking. This detection, however, confirmed that intelligent life, if it does exist, can survive in extremes. It held out the possibility that the so-called rare earth theory was incorrect, and that life could thrive in much more varied circumstances than had been thought. For climatologists, the find raised a plethora of intriguing questions. What type of energy infrastructure might be required to provide such light on a planet around a comparatively feeble red dwarf star? Might they have adapted sophisticated solar capture technology to store power over timescales of thousands of years? Or had they accessed geothermal resources, harnessing the Earth's internal heat to energize their worlds? Did nuclear fusion, or even more advanced kinds of energy, play a role? The fact that a civilization was able to illuminate a hemisphere without upsetting its ecology implied a high degree of energy management, something that humanity is still learning to do, and do well, today. Sociologists and anthropologists were soon on the discussion. What type of civilization decides to illuminate the night? Is nighttime lighting a global manifestation of technological progress, or is it culturally determined? Might the light meshes indicate a collectivist culture, densely coordinated and hierarchical? Or might they indicate a competitively fragmented mosaic of independent city-states, all competing for power through technologies? The pattern and brightness of the lights suggested population densities, economic hubs, and even possible transport channels, all set in patterns which mirror Earth's own progress in eerie detail. The effect on the famous Drake equation was instant. The find presented a tangible data point for the elusive factor of the number of civilizations with long-term technological survival capability. Until this moment, it had been sheer conjecture. But to be able to see city lights shining across the gulf of space provided proof that intelligent civilizations could, in fact, last long enough to develop to an energy mastery level detectable light years away. It implied that with intelligence arising, the development of global infrastructure and survival over the long term could not be as uncommon as previously feared. The technological implications for mankind were also mind-boggling. Here on Earth, street lighting is not only an indicator of progress, it's a measure of technology capability, political stability, and environmental trade-offs. For Proxima b, the existence of such light means sophisticated grid management, perhaps with solar, wind, and other renewable power sources, storage devices, and long-distance transmission lines. Even the geometry of the light distribution hinted at long-distance transmission lines, perhaps even involving superconducting materials or beamed energy. Certain speculative commentators suggested the employment of orbital reflectors or power satellites to improve lighting efficiency. Whatever the technologies, they indicated a civilization that had overcome many of the issues presently confronting humanity. It was all made possible through the sheer genius of Webb's design. Its segmented mirrors, each carefully crafted and placed, formed a telescope with unrivaled resolution. Its enormous sunshield allowed instruments to cool to only a few degrees above absolute zero, suppressing internal thermal noise and enabling extremely clean data. It was not just a telescope, it was a time machine and a cosmic microscope rolled into one. We were no longer searching for life for the first time. We were reading the fingerprints of civilization. The discovery also highlighted the strength of global scientific cooperation. Astronomers and engineers from all continents made this mission a success. Amateur astronomers supplied valuable flare monitoring data to calibrate the Webb's observations during low stellar activity times. Software engineers at Silicon Valley authored machine learning algorithms to sort out false positives. Research institutions contributed computing power to process the vast amounts of raw image and spectral information. The whole endeavor was a victory of international collaboration, evidence that humanity's search for knowledge of the universe can make us one despite language, border, and political differences. When word of the find leaked out, more profound, metaphysical questions gained traction. How old was this culture? What had they survived to arrive here? If Proxima b is 4.8 billion years old, and life arose early in its history, then its residents could have had a significant advantage over humanity. The height, brightness, and sophistication of the lights indicated a civilization that had developed over centuries, quite possibly millennia. Did they weather planetary catastrophes? Had they endured extinction events, ideological revolutions, or technological singularities? Or had they attained a degree of sustainable equilibrium much sooner than we have? Then there were the philosophical and theological implications. Human beings have wrestled with the concept of cosmic isolation for centuries. The Copernican and Galilean revolutions removed Earth from its privileged position at the center of the universe, but the question of other minds, other civilizations, remained in doubt. Now, Webb had provided an answer. Theological thinkers contested whether or not ancient writings had foreseen the potential for other conscious forms of life. Some found confirmation, while others were unsure. Meanwhile, philosophers were inquiring as to whether we now had a duty, not merely to watch, but to interact. Should we make contact? If so, then how? What message should human beings send across the light years? Detection of city lights also reoriented the very course of space exploration. Missions formerly envisioned as strictly scientific were now politicized. If a being on Proxima B could ignite their planet, they may quite literally be observing ours. Probes would not be launched blindly anymore. There were new debates regarding the morality of interstellar communication, with many promoting symbolic artifacts, mathematical constants, musical patterns, even genetic maps, as hesitant overtures of contact. Committees were organized to debate what humanity ought or ought not to impart. In the meantime, planetary protection specialists cautioned that even passive monitoring may impact extraterrestrial ecosystems if conducted with no care. Lastly, the discovery sparked an unsettling question: had we already been noticed? If city lights could be seen by us, could our own light at night be seen by others? And if they can, have they already reached out to us in ways we've not known? Or are they still deciding, as we now are, whether to risk a hello? Ultimately, the discovery of city lights on Proxima B is not only a milestone for astronomy, it's a moment of turning in the history of humanity. It's a reflection held up to our species, revealing both our potential and our weakness. If they exist, then we are not alone. And that fact transforms everything: science, religion, the destiny of civilization itself. If this revelation was as astonishing to you as it was to us, be sure to hit that thumbs up button and subscribe to our channel for further news on humanity's biggest scientific endeavor. And we'd love to get your take. Did Webb really catch a glimpse of a civilization out there? Or is there some other theory that we're yet to think of? Share your theories in the comments. Thanks for watching, and until next time, keep looking up.